Okay, so this is the 2022 AMC 12B number 10. So we have a regular hexagon with the sides 2, and then G is the midpoint of AB, H is the midpoint of DE. What is the perimeter of GCH? Okay, so let's start with drawing the hexagon. So since we are told that's the regular, so let's try to make one. So I'm gonna have these two. Okay, and then I should have something like this. So again, it doesn't maybe look like exactly regular, but it's okay. So let's say this is my regular hexagon. So I need to keep this order. So it doesn't really matter where you started, but after you start, it doesn't matter how you write it. So you can go either this way or this way. So I'll go with B, C, D, E, and F. Okay, so we are told each side is 2. So let's write these guys as 2 as well. And then G is the midpoint of AB. Okay, so I'll take the midpoint of AB. That's my G, so that's 1 and 1. And H is the midpoint of DE. So this is my uh, H. Okay, so that's going to be midpoint of that. So maybe I should label this. And that was my point G. And the perimeter of GCHF. Okay, so let's connect those. So GC and HF. Okay, so that looks like we have this figure. Okay, so, and then I will continue finding the remaining part. Okay, so we do have a regular hexagon, and we probably need to know the angle. So if I divide 360 by 6, I will get 60, which is gonna be just one of the exterior angle, right? Because the sum of the exterior angle of any polygon is 360. When you divide by number of sides, you get exterior angle. So which means if you extend this piece, so that is 60, the inside will be 120. This is one way. Some people are gonna probably remember n minus 2 times 180 is sum of the interior angle of any polygon. And then if you divide this by n, you get 1 interior as well. So if you do use this one, since we have 6 sides, so that will be 6 minus 2 times 180 over 6. And I can divide this, that will be 30 times 4, which is also 120. So you could do the either way around. So I guess this is kind of what I like most, but it's also fine. And now we do need to find the this side, but at the same time, this side, and this side are actually the same, because since this is regular hexagon, these are all equal to 120, and this is also 120. And since we are told this was midpoint, and this this is 1, this is 2, this is a triangle with 2 sides, 1, 2, and the same thing going on right here, same thing going on right here. And these two, like these 4 triangles, are actually congruent because 2 sides are equal and the angle between those 2 are equal. So they are congruent by side angle side, okay? Congruency. So if they are congruent, so this middle figure that we are trying to find the perimeter is actually a rhombus. So if you know the one side, then we are done with that question. So after this point, I will try to do this 2 different ways. One of the ways is, as soon as I see 60 degrees, I feel like it's good to remember 30, 60, 90. Okay, so I'm gonna extend this line, okay? And then I will drop a 90 degrees from there so I can make actually right triangle. So when I do this, this is 60 and this is 30. So if you don't remember, it's good to review this special right triangle. So if I do kind of make it bigger, so it will be something like this. And since we know this BC, if I write this is BC is 2, and this is 30 degrees, and this is 60. And in 30, 60, 90 triangle, the 30 degrees will be opposite to the side that is half of the hypotenuse, which is why this is 1. And the other leg will be smaller leg times √3. So that is going to be √3. So that is √3, and this is 1. And now I do have another triangle that I need you to just focus on. So look at this right triangle. So I do have two legs. I just need to find the hypotenuse, so I can use my Pythagorean. So let's do that. So if I use the Pythagorean, so I'm gonna call this as hg squared, which is 2 squared, and then plus root 3 squared is equal to gc squared. Okay, so that's 4, that's 3, that's gonna be 7. So if you take the square root, so that will be root 7. GC will be root 7. And if this is root 7, we have 4 copies, FG, FH, and HC. So which is why we do get this answer. So this is one thing I can do. The second thing is actually using a bit of trick, which is law of cosine. And I will just kind of separate this solution from the other one. So, you know, whenever we did like get this 1 and 120, and other than using these specialized triangles, I can actually take maybe the same triangle right here and use my law of cosine. So if this side is x, so let's call this is x, the square of this is equal to the sum of the squares of the other sides, which is 1 square plus 2 squared minus 2 times 1 times 2 times cosine 120. Again, if you don't remember such a thing, so it's better to review the law of cosine. So I did have a proof for this relation. You can take a look at. And that is x squared. And that's basically 5. And that's going to be 4 times cosine 120. So if you don't remember the cosine 120, which is actually something we need to remember, this is equal to negative of sine 60. I mean, cosine 60. Let me write that. Negative version of cosine 60. And if you don't remember this as well, so you can actually use the right triangle, which will be useful. So if you write this is 30, 60, 90, okay, so that's x, that's 2x, and this is x root 3. So cosine 60 will be adjacent over hypotenuse, which is 1 over 2. But since this is going to be minus, so I will get minus 1/2. So as you see, whenever you really want to use the law of cosine, you should still use the 3690 triangle. So which is why maybe first approach was better than the law of cosine. But anyway, I just did both ways. So we can actually see we can use the law of cosine as well. Okay. So that x squared is gonna be, this is gonna be just plus 2, and 5 plus 2 will be 7. So x will be root 7. So x is root 7, so we have just one of them. So if you double multiply that by 4, you actually get the same thing. So again, the question just can be done a couple of ways, but law of cosine is something we can apply in this case as well. I'll see you in the next video.